Our Unit 4, Day 6 is a lesson on word problems where we are using rate of change and the slope-intercept form a lot of times to find equations that match our word problems, and also those equations will help us if we need to find further information. So our first problem is a band marches 1,560 feet in 5 minutes and then 3,240 feet in 12 minutes. So what is the rate of change? So remember, rate of change is going to be our slope. So if we can write two ordered pairs, we can find our slope. Remember, slope is, there you go. Slope is y sub 2 minus y sub 1, or change in y over x sub 2 minus x sub 1. Okay, so I need to decide what is my x value and what is my y value here. I have a certain amount of feet and I have some time. So when I look at this, it seems to me that the number of feet we've gone depends on the amount of time we've been marching. So I'm going to say this first piece of information is 5 minutes, 1,560 feet. And so my other piece of information is in 12 minutes we go 3,240 feet. Okay, so now we're just going to find our slope, and when we find our slope, we know that that is going to be y sub 2 minus y sub 1, so 3,240 over, minus 1,560, all over 12 minus 5. Okay, and that simplifies to 1,680 over 7, which equals 240. And when I think about what this really means, it really means 240 feet per minute. Feet per minute sounds like a rate, and so that seems like I probably did that right. 240 feet per minute. Okay, for our next example, Kelly is on a plane getting ready to return to JFK Airport in New York City. Starting at the beginning of the descent, time equals 0. The plane is at an altitude of 5,575 feet. But then at 10 minutes, the plane is 3,325 feet above the ground. So we see that the altitude is decreasing, it's going down, right? We want to find that rate of change, and so I know that at time 0, I'm at 5,575 feet, and at time 15, I'm at 3,325 feet. So I can solve this using my slope formula. I have 3, 3, 2, 5, minus 5, 5, 7, 5, all over 15 minus 0. And I end up saying that that is negative 2,250 over 15, which is negative 150 feet per minute. And that makes sense because we are descending, we are going down, and feet per minute is a rate. All right, so the next section we're going to do here, we're going to fill in each of the blanks using a word bank. Our words are positive, negative, 0, and undefined. And if you remember, on a coordinate grid, a positive slope is going to go uphill from left to right. A negative slope is going to go downhill when you look at it visually. If we have a slope of 0, it's a horizontal line. Remember, Vux and Hoy, that's a horizontal line. And an undefined slope is that vertical line. Okay, so number 3, when the dependent variable increases, as the independent variable increases, the rate of change is. So if I am increasing dependent at the same time that I'm increasing independent, they're both increasing at the same time, I have a positive change. When the dependent variable stays the same as the independent variable increases, the rate of change is. Well, in this case, the dependent variable is my up and down, right? My y-axis. And so if I am moving to the right on my x-axis, but I am not changing at all on my y-axis, then I have a slope of 0. When the dependent variable increases as the independent variable increases, sorry, I didn't read that properly. Let me try again. When the dependent variable decreases as the independent variable increases, so I am traveling on my x-axis to the right, and my dependent variable on the y-axis is coming down, that's going to be my negative slope. As I go to the right, my vertical axis is dropping, my vertical point is dropping. So I'll have a negative slope. And then when my dependent variable increases as the independent variable stays the same, so remember, independent variable is my x-axis, right? It's going to stay the same. X is not going to change. But my dependent variable is increasing, so the rate of change is undefined because that would make a vertical line. Okay, so we're going to go ice skating with our friends right here. You go ice skating with your friends. It costs $12 to rent skates for $3 for each hour. Sorry, $12 to rent skates and $3 for each hour that you are on the ice. We just need to write an equation in slope-intercept form to represent the situation. Okay, y is the total cost, x is the number of hours. So when I think about what this means to me, if it costs $12 just to rent the skates, that's going to be my base fee, right? And then if it's $3 for each hour, per hour, for each hour, every hour, that's going to be my rate. So my rate of change is also my slope. So I'm going to say my slope is 3. My base fee was $12. And I need slope-intercept form, so I'm going to remind myself that slope-intercept form is y equals mx plus b, because I have a slope and I have an intercept. So I ought to be able to write this, right? I know y equals 3x plus 12. $3 per hour is how much I have to pay to go ice skating, plus $12 to rent the skates in the first place. Okay, after 8 weeks on a fitness program, Greg can jog 30 miles a week. His average mileage gain has been 2 miles per week. So 2 miles per week is going to be our rate of change, right? That's going to be a slope. Okay, and we're going to write an equation again in slope-intercept form, so make sure that you're using that form. It's going to give Greg's mileage in terms of the number of weeks he stays. Oops, you can't see my m equals 2. Forgive me. Sorry. I know 2 miles per week is my slope because that's my rate of change. So we need to write an equation that gives Greg's mileage y in terms of the number of weeks he's on that program. So we want to think about what is given to us. The slope, the y-intercept, a point. So which equation of the line would be the easiest to start with? It might not be slope-intercept. All right, so I'm going to look back up here. We know after 8 weeks on a fitness program, Greg can jog 30 miles per week. So that's what he's going to do. All right, so I am going to use that information and give myself a point to start with. Okay, in 8 weeks, he's jogging 30 miles. Right, so I have a point and I have a slope from right up above, right? My slope is 2 miles per week. And so I'm going to use, I have a point and I have a slope. I'm going to use the point slope formula. Remember, that is y minus y sub 1 equals m times x minus x sub 1. So I'm going to plug in everything I know here. I know y minus 30 equals 2 times x minus 8. So I now have an equation of a line, but the problem asked me to write this equation of the line in slope-intercept form. So I need to rearrange it. That's basically solving for y. Remember, we want y equals mx plus b format. So I'm just going to simplify and solve for y. I start by saying y minus 30 equals 2x minus 16. I'm going to add 30 to each side, so I have y equals 2x plus 14, and that's my answer. All right, so if you flip your page over, you'll see that we have some more word problems. Number 9, Christina withdraws $7.50 per week from her savings account. She's withdrawing money, so her rate is going down, her amount in the end is going down, right? So after 12 weeks, the balance in her account is $452. We need to write an equation in slope-intercept form that gives the balance y in terms of the number of weeks x. All right, so she is withdrawing $7.50 per week. So my rate, or my slope, is negative 7.5, negative 7.50, right? She's withdrawing, so we're going down, okay? And I have some information about 12 weeks. She has $452. So I could write myself an ordered pair At 12 weeks, she has $452. And we know that her M, slope, rate of change, is negative 7.5. It's going down $7.50. I'm going to use the point slope form to start this, and then I will convert, because my question has asked me to write the answer in slope-intercept form. So the first thing I'm going to do is point slope. Y minus 452 equals negative 7.5 times x minus 12. That becomes y minus 452 equals negative 7.5x plus 90, because we're multiplying negative times negative. This is going to equal y equals negative 7.5x plus 542. Okay, I want to double check that I've written in slope-intercept form. I need a slope, I need the intercept. Y equals negative 7.5x plus 542 follows the slope-intercept form. So that's my answer. Number 10, we're on a farm. The average weight of 7-year-old pigs is 49 pounds. The average weight of 11-year-old pigs is 77 pounds. So we want to use this information, and we're going to ultimately write our answer in slope-intercept form. And we're going to give the average weight y of pigs who are x years old. So I have 7-year-old pigs at 49 pounds, and I have 11-year-old pigs at 77 pounds. That seems like 2 points to me. So I'm going to write that I have 7-year-old pigs at 49 pounds, and I have 11-year-old pigs at 77 pounds. So I have 2 points. So I am going to choose to find the slope. M is the change in y, 77 minus 49, over the change in x, which is 11 minus 7. My slope equals 7. This is 28 over 4, which equals 7. And to get myself an equation in slope-intercept form, I need an intercept. So I have 2 options here. I can either use this slope and an x and a y and find this in slope-intercept form. I can find my missing b, or I can start with point slope formula and then convert back to slope-intercept. I'll start with the y equals mx plus b. So this is ultimately what I want my answer to be, but you can do this problem either way. Okay, I'm going to use my first point here. Okay, 749. So I have a y, 49, equals, I have my m, that's 7. I have my x from my original point, 749, so there's my x, plus b, and I'm looking for b. That's what I'm trying to find out. Okay, now I know 49 equals 49 plus b, and if I subtract 49 from each side, I get 0 equals b. So I now know b, my y-intercept, and m, my slope. So y equals 7x plus 0, but I don't even need to write that, right? So that is a fine way to write slope-intercept form for this problem. Okay, Bob is traveling. He's traveling home at a constant speed, and after half an hour, which is 0.5 hours, he's 77.5 miles from home. After 1 hour, he is 55 miles from home. So his distance from home is decreasing, right? Because he's coming home. We need to write an equation in slope-intercept form. It's going to give the distance from home, y, in terms of the time, x, right? So I see that after half an hour, 0.5 hours that is, he's 77.5 miles from home. So I have 0.5. He is 77.5 miles from home. The other information is after 1 hour, he is 55 miles from home. And so now I need to find my equation. So first, I'm going to look for the slope, or the rate of change. Okay, so my slope is going to be y sub 2 minus y sub 1, so that's 55 minus 77.5, all over x sub 2 minus x sub 1, so that's 1 minus 0.5. My slope is going to be negative 45 miles per hour. Okay, miles per hour is a rate or a slope, so that makes sense. And it's negative because his distance from home is decreasing. He's getting closer to home. All right, so now I have 2 points and I have a slope to work with. So I'll probably just use point slope formula here. So I'm going to use my second point because there's no decimal, and there's a 1 in there, which is probably going to make life easier. So I'm going to say y minus 55 equals negative 45 times x minus 1. I just plugged in the information from this second point. And so I need to say y minus 55 equals negative 45 plus, negative 45x plus 45. And then I'm going to add 55 to each side. So I have y equals negative 45x plus 100. And that's my final answer right there. All right, we're almost done. We just want to write the equation of a line in slope-intercept form. So I need a slope, and I need a y-intercept for each of these functions. All right, so I can find slope. I can choose any two ordered pairs here. Remember, each one of these gives me an ordered pair x comma y. So I'm going to write two ordered pairs side by side. I have 4, 10, and then 2, 4. Okay, I can find my slope. Slope is going to be 4 minus 10 over 2 minus 4. So I have negative 6 over negative 2, which is positive 3. I have found my slope. The slope is positive 3. All right, is the y-intercept in the table that is already provided to me? At the y-intercept, I know my x value has to be 0. So I'm looking in the x column to see if there are any zeros, and there are not. So no, it's not included. So I have to find it myself. So what I'm going to do then is I'm going to use any one of these points, and I'm going to use the point slope formula. I'm going to use this point, 2, 4, as the point that goes into my formula, just because they're smaller numbers and they're both positive. So if I say y minus 4 equals my slope that I found, 3 times x minus 2, I can solve until I end up with a slope-intercept form of this line. Y minus 4 equals 3x minus 6. Remember, we're distributing that. And I have y minus 4. Oops, excuse me. Oh, goodness. Okay, sorry for that brief interruption that we had. So we are solving here, and we want to have this line be in slope-intercept form. And so I'm going to add 4 to each side, and so I have y equals 3x minus 2. All right. And for our very last table, my slope. I need to find the slope. I'm going to choose 2 points that I'm willing to use. I'm going to use 6, 7, and 0, 5. You can choose any 2 points. I like those because they're all positive. Okay, so I have 5 minus 7. My slope is 5 minus 7 over 0 minus 6. And so it equals negative 2 over negative 6, which is the same as 1/3. My slope is 1/3. And the question is that y-intercept included in the table? Again, the y-intercept is going to be the point at which the x value is 0. And so what we're going to do is we're going to say that this is our y-intercept. And so I have y equals 1/3 x plus 5. And so that's my equation there. Great.